In this video, I'm going to go over how we simplify simple radicals, and we can use the quadratic formula. So I'm going to start with simplifying radicals. So you guys should be familiar with things like the square root of 16, which is positive or negative 4. The square root of 25 is positive or negative 5. But what if you have a value that doesn't have a perfect square, like that isn't a perfect square? So let's say that we have the square root of 20. Okay, now this one does not solve simply, but we can actually simplify it. So the way that we do this, we are going to break it down by all of its factors. So 1 and 20, 2 and 10, 4 and 5. And what you're going to do is you're going to look for all the perfect squares in the list of numbers. And if you don't know what the perfect squares are, I will write the first 20. So we have 1, or not the first 20, the first 10. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So I actually went to 15 just because I had that space. So if I'm looking at this list, I do have 2 perfect squares. I have 1 and I have 4. Now what I want to do is I want to pick the greatest perfect square. So if I were to pick the greatest perfect square, I have 4. So I would rewrite this as the square root of 4 times the square root of 5. And from here, I can take it one step further to simplify. The square root of 4 is positive negative 2. And root 5 is going to stay the way it is. And the way that you kind of say that out loud is 2 root 5. So that would be a simplified radical. So this right here would be your new answer. Okay, so let's try another one. Let's say that we do the square root of, gotta think of a number that works. Let's say that we do 27. Okay, I'm starting with smaller numbers. We'll come up with bigger ones later. But let's come up with the factors. We have 1 and 27, 3 and 9. So there's only 2 perfect squares again. We have 1 and 9. The greatest perfect square being 9. So I can rewrite this as the square root of 9 times the square root of 3. And you're going to notice that even though I'd written this as 3, 9 here, I rewrote it with my perfect square first, because I know I'm going to be able to simplify this. So the square root of 9 can be simplified to positive negative 3, and root 3 is going to stay the way it is. So 3 root 3 would be the simplified version of square root of 27. Okay. Hopefully that made a little bit more sense. There will be some practice if you need some more. We're going to move on to the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I know that sounds really complicated, but your only job here is to plug in each value and simplify. And within that, we have something called the discriminant. And the discriminant is simply this square root thing. So the discriminant is just b squared minus 4ac. There's a separate set of notes about this, and you guys can check that out. There won't be a video about it, but just as kind of a little note for you guys, if it is a positive number, there's 2 roots. If it is a negative number, there are no roots. And if it is 0, there's 1 root. All right, now let's go back to talking about our quadratic formula. You should notice that there are 3 unknown letters here. Okay, we've got B, we've got A, and we've got C. And where those numbers come from is actually our standard form of a quadratic equation. So if we had y equals ax squared plus bx plus c, a, c, and b are the same thing. So my c is coming from here, my a is coming from here, and my b is coming from here. So let's try one out. Let's say that I have y equals 3x squared plus 5x minus 4. Okay, so let's say that that's where I'm starting. All right, and I have my c value. I'm going to take that negative with it. I have my b value. And I have my a value. And what I'm going to do is I'm going to slowly input them into my equation. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to start inputting, all right? X is equal to, my b value right here is 5, so negative 5 plus or minus the square root of b squared, so that's going to be 5 squared, minus 4, then I'm going to multiply it by a, which is 3, and c, which is negative 4, all over 2 times a, which is 3. Now, this looks kind of complicated and ugly, but all we're going to do from here is start to simplify. And we're going to do it in pieces. So we're going to start with the discriminant. So we have x equals negative 5, we're going to keep that there, plus or minus the square root. So first step, 5 squared. And if you don't have a calculator, you can do it in your head. It's 5 times 5, so that's going to be 25. Then negative 4 times 3 is negative 12, and negative 12 times negative 4 is positive 48. So another way you could do that, if you wanted to, you could literally type into your calculator all of those numbers. You could type in negative 4 times 3 times negative 4, and you get out positive 48. So, and that is all going to be over 6. My next step is to do x equals negative 5 plus or minus, and I'm going to simplify what's in those parentheses. So 25 plus 48 is going to get me 73 all over 6. Now, technically, you could leave this as your answer. Okay, this represents my roots. However, what I'd like for you guys to do is using a scientific calculator, and there is going to be one on your quiz, I want you to actually type this in. Okay, so I'm going to show you how I would do it. So I'm going to type in negative 5, and I'm going to start with the plus. Actually, take all that back. We're going to start over. Start with your parenthesis. Negative 5 plus the square root of 73, and I'm going to close that parenthesis because this whole thing is the top of my fraction. I'm going to divide the whole thing by 6. So one of my roots is going to show up on or at 0.59, all right, or 59 hundredths. I'm going to do all this again, but where the plus sign is, I'm now going to use my minus sign. So negative 5 minus the square root of 73 all over 6, and negative 2.26, because that 7 is going to bump that 5 up, is going to be my other root. Okay, so those would be my 2 roots. So essentially all you're doing is simplifying, and the reason I taught you simplifying radicals is because you could also try and simplify this radical. 73 doesn't actually simplify, it is a prime number, so it would stay exactly as it is. But please use the calculator to your advantage, And I do want you guys to see, if I try and type this into the calculator without the parentheses, you're going to notice that the answer shows up wrong. So if I were to type this in without the parentheses, you're going to see it comes up with a different answer. The reason is, what your calculator is doing is it's doing the square root of 73 divided by 6 first before adding -5 to it. So you have to have those parentheses there to make sure that it's doing it in the right order.